the degree of collusion in an industry. Okay, so the most classic model of oligopoly is Cournot's 1838 model, and Yifei. What's the basic idea of Cournot's model of oligopoly? Don't read off the slides. Don't read off the slides. Come on. What is the Cournot model of oligopoly? If you even open variant, you know this. This is the first thing in the chapter. No. Okay. Who else? Who else? Yeah. What's your name again? Chen.
Reaction to the purchase between the companies. They take the price. They take the quotation of the other companies.
Each firm takes as yes, exactly. Each firm takes as given the quantity that the other firm produces, and then produces the quantity that maximizes its profits given them. Right? Okay. So there are n firms, and they each produce the same product, the same homogeneous product. We'll often assume that all the firms have the same constant marginal cost of production, and each firm takes as given the quantity of all the other firms. This is sometimes, and I think a bit misleadingly, referred to as the firms choosing the quantities that they produce, but really it's not that they're choosing the quantities they produce. They could choose their price. The key thing is whenever they do anything, they take as given the quantities produced by the other firms. And then equilibrium is when each firm maximizes their price, their profits using their price or their quantity, taking as given the quantities chosen by all the other firms. So let's consider how they do that. Each firm is going to earn profits, which are the quantity they produce, times the price, which depends on their quantity, and the quantity of all the other firms, which is going to be this capital Q sub negative I minus cost. So again, the quantity of all the other firms is Q sub negative I. Negative I means not including me, not including I. And capital Q is just the sum of all the little q's. And then what is going to be the firm's marginal, what's going to be the firm's marginal revenue, Maria? So this is their quantity, this is the price. What's the marginal revenue? The derivative of quantity times price.
Yeah, so quantity times the price of just Q minus.
So the derivative of QI times P of...
Oh, like QI and then like Q.
Yeah. So what's the derivative of that?
In terms of, right, just PQ plus PQ.
Yeah, you want to come work it out on the board maybe? Whenever you take these revenue things, you always just use the product rule, right? Right?
Yeah.
What's the product rule? The derivative of the first
Yes.
times the second plus the derivative of the second times the first, right? And when you took the derivative of the first, right, you don't get the Q because then the derivative of that is 1, right? Yeah, so it's so close. It's P prime Q times QI plus P of Q, right? Because it's the derivative of the first, which is just 1, times the second, which is P. So that's the derivative of the second, P prime times Q. Okay. So marginal, note that because my quantity is less than the total quantity of the industry, this term, the Qi times P prime, is going to be smaller than it was for the monopoly. Because the monopoly had the whole industry quantity here. Now the individual firm only has this little quantity, Qi. That is, they care less about keeping the prices up when they're only producing a small part of the total amount in the industry, right? And so this is very simple, particularly simple with symmetric firms. Imagine all the firms produce the same quantity. Each firm has 1 over n of the total quantity of the industry. Sorry, I haven't been consistent about whether n is capitalized or not. Sorry about that. So when there's n firms, the quantity of each individual firm is then 1 over n of the total industry quantity. And so we just put a 1 over n here, and then we can derive Lerner's rule as we did before, and the term with the 1 over elasticity just gets a 1 over n multiplied by it. So the markups go down, right? Price minus cost over price is now, rather than 1 over elasticity, equal to 1 over n times elasticity. Okay. So let's do a simple example of this. Imagine that there's a constant elasticity of demand with an elasticity of 1. And imagine that the marginal cost is equal to 1. So, Naveed?
Yes.
Hey. What demand form is constant elasticity of demand with an elasticity of 1?
That means everybody demands the same.
So if the industry is a constant, if the demand elasticity of demand is constant and equal to 1, what is the demand?
Would it be linear perhaps? I'm not sure.
You can come and solve for it if you want to try to, or you can just give up.
Sorry, I don't know.
Okay. Does anyone else know? Yeah.
P equals to 1 of Q.
Yeah.
Just using the CES equation.
Yeah, it's just, so what we did before, right, is that constant elasticity is always something to the power, right? And that if it's just an elasticity of 1, it's just got to be the power of negative 1, right? Because it's decreasing. So price is equal to 1 over the quantity. And therefore the derivative of price, P prime, is negative 1 over Q squared, right? That's just using the derivative of a power thing. So marginal revenue is going to be quantity minus marginal revenue is going to be price 1 over quantity minus my quantity times P prime. So that's Q minus Qi over Q squared, which is the same as the quantity of everyone other than me. Q sub negative I over Q squared. Yes, absolutely. Okay, so marginal revenue is price plus price prime times my quantity, Q little I, right? So that's the same as 1 over Q minus Qi over Q squared. We can then make a common denominator between those two things by multiplying the top and the bottom of this by capital Q, and we get capital Q minus Qi over Q squared. And that's equal to the total quantity minus me, which is equal to Q sub negative I over Q squared. Okay. So each firm is going to set this marginal revenue equal to 1, right? Because that's their marginal cost. constant marginal cost of 1. So each firm is going to set this thing equal to 1, which is the same as having 1. Okay, let me just do this on the board. So quantity minus QI over quantity squared is equal to 1, right? So we can rearrange that as 1 over quantity minus 1 is equal to QI over quantity, right? And now, imagine I'm now going to add this up across all the firms in the industry. Sum over all the N firms. Patrick? Yeah, Patrick? What equation would we get then if we add that up over across all the firms? All the firms have this little QI, right? And we know that capital Q is the sum of all the QIs, and that there are N firms. So what do we get if we add both sides of this equation up over all the firms? Summation over I of QI over Q squared, and here we get the same, right?
Yeah.
But then what is the summation over I of QI? You're going to get capital Q on the left-hand side, and what do you get on the right-hand side? Well, there's no little q's here, right?
Oh, yeah.
You're just summing up the same thing n times,
Correct.
right? So you're just going to get n times this expression on the right-hand side, right? So you get, on this side, you get capital Q over Q, capital Q squared. That's 1 over Q. Here you're going to get n over Q minus n, right? So then let's just multiply both sides by Q, and you're going to get 1 is equal to n minus n times Q, right? Which is the same as if we just put this on the right-hand side, Q times n is equal to n minus 1, which is the same as Q being equal to n minus 1 over n. So what does that say? As n gets large, the quantity goes to the efficient quantity, which is 1. Right? Because if the price were equal to 1, we would have the quantity is equal to 1. Right? So we'll talk much more about this particular result on Tuesday, and we'll do this math over again. But the key point is that while the industry quantity goes to 1, each individual firm, which is only 1 over n, is going to go to 0. Right? So each firm produces almost nothing, but the industry as a whole produces the efficient amount. Now, when we have just 2 firms, there's a nice way to represent this graphically. And Eric? Is Eric here? No. No, not you. Eric. The way we can do this is we can figure out what each firm produces as a function of what the other firm is going to produce, right? This is called a reaction function. So you can say, okay, well, we have this equation, QI over the sum of the 2 quantities squared is equal to 1 over Q minus 1. That's the same as saying what I produce divided by what I produce plus the other guy produces squared is equal to 1 over the sum of those 2, minus 1. So that's the same as multiplying through by this squared. We can cancel here, and then we get it squared there. Expanding that out, we get QI from this side is equal to QI plus QJ minus QI plus QJ squared, which is the 2 squares minus 2 times the product of the 2. Right? And canceling things out, we get this expression.